Dear students, welcome to our science episodes. Today we are going to discuss energy transformations. Energy transformations. This is the first activity. Push with your hand gently a simple pendulum, then leave it. A simple pendulum is a pendulum as the one in the picture with only one ball. Observation. The ball of the pendulum moves to the right and to the left from the rest position. As you can see, it's moving right and then left, right, left, right, left. Its speed decreases when it goes far away from the rest position, and the maximum speed of the ball is seen during passage through the rest position. So the maximum speed is here. This is the rest position, the red dotted line. The maximum speed is at the rest position, and whenever it goes far from the rest position, its speed decreases. The conclusion is work is done when lifting the ball upward. This work is stored in the form of potential energy, and then when it is left, potential energy is converted to kinetic energy until it reaches maximum speed, and this is repeated while the pendulum keeps its mechanical energy. Can you see this picture? In point B, which is the rest position, here the maximum kinetic energy, because we said the maximum speed and minimum potential energy. The mechanical energy here at point B is equal to its kinetic energy. At point A and C, when the pendulum is going far right or far left, this is the maximum potential energy, and the kinetic energy is 0. The mechanical energy at point A and C is equal to its potential energy. This means that the body maintains its mechanical energy where potential energy interchanges with kinetic energy, neglecting air resistance. Here is activity number 2. Repeat the previous procedure but using a compound pendulum. We said that the simple pendulum contains only one ball, but the compound pendulum contains more than one ball. What is your observation? The movement of the ball on the right side causes the other balls to move, and then the movement of the ball on the left side causes the other balls to move, and so on. The right will move, moving the others, then the left will move, moving the others. Right, left, right, left. The conclusion is kinetic energy is interchanged between the balls of the pendulum while hitting each other. When two objects are hitting each other, potential and kinetic energy are interchanged between them, keeping mechanical energy constant. Can you give reason? How does the movement of a swing resemble the pendulum? Here is a swing. Look to this girl. She's swinging from point B, the rest position, to A, and then to B, and then to C. Why this movement resembles the pendulum? In both the swing and the pendulum, the potential and the kinetic energy are interchanged without ending, from potential to kinetic and from kinetic to potential and so on, where the sum of the two energy at any moment is equal to the mechanical energy, which is constant. Here is a problem for you. In this pendulum, the potential energy at 0.4 meter height, which is the point A, is 0.8 joules, and the potential energy at the rest position, point B, is 0.2 joules. Calculate the kinetic energy at point B and the mass of the ball. He's giving you the height, which is 0.4 meter, and he's giving you the potential energy at point A, maximum height, and potential energy at point B, the rest position. He wants to know the kinetic energy at point B and the mass of the ball. First of all, the mechanical energy is equal to the potential energy at point A at the maximum height, which is equal to 0.8 joules, where the kinetic energy is almost zero. At point B, we know the mechanical energy, which is 0.8 joule, and it never changes, as we said before. And the potential energy at rest position, point B, equal 0.2 joules. So we can get the kinetic energy by subtracting 0.2 from 0.8, which is equal to 0.6 joules. This is at point B. Then, at point A, the maximum height, potential energy equal weight times height. So the weight here is equal to the potential energy divided by the height, which is 0.8 joules divided by 0.4 meters equal 2 newtons. Weight equal mass times acceleration of gravity. So mass equal 2 divided by 10 equal 0.2 kilograms. Here is a simple electric cell using a lemon. Sometimes we call it lemon battery. Materials. You have to have a large lemon, a small compass, a copper wire, a zinc rod. A copper wire and a zinc rod. What are the steps? After softening the lemon, you will insert the copper wire and the zinc rod in the lemon. After softening the lemon, you will insert the copper wire and the zinc rod in the lemon. Connect the copper wire and the zinc rod to a compass. What is your observation? You will find that the needle of the compass will move. And the conclusion is, the lemon contains an acid solution. The chemical energy inside the lemon is converted to electric energy. And the acid solution, of course, is a good conductor of electricity. What will happen if the lemon is replaced by a tuber of potato? Potato? Yes. The solution inside the cells of the potato will act as the acidic solution of the lemon, and it will conduct electricity and the needle of the compass will move. Now, this is a simple electric column. It is composed of a trough containing diluted sulfuric acid, H2SO4, solution with two different metal rods dipped in and attached by a wire. The two metals are zinc and copper. Zinc at the cathode, the negative pole, while copper is at the anode, the positive pole. The chemical reaction converts chemical energy into electric energy, and the light bulb will lit. Here is an electric circuit. It is composed of a dry cell or a battery, a switch, wires, and a light bulb. If you can make a simple electric circuit like this, like the one shown in the figure, and then switch it on, what will happen? Of course, the light bulb will lit. Be cautious while touching the glass of the bulb. Observation: the light bulb will lit. It becomes hot by time. And the conclusion is, electric current will flow through the wires, causing the lighting of the bulb, and electric energy is converted to light and heat. Let's have a look at this example. This is an example of energy transformation in a car. First of all, we use petrol. It is a source of chemical energy. When this fuel is combusted or burned, heat energy will result. This heat energy will cause mechanical energy in the motor of the car, and then the car will move. When the car will move, some of the mechanical energy is converted by the dynamo into electric energy. And this electric energy will be converted into light energy while using the lights of the car, to sound energy while using the stereo of the car or the MP3 player, and to heat energy while using the AC when it is too cold. Again, to wrap it up, chemical energy from fuel, combustion, into heat energy. This heat energy will be converted to mechanical energy used by the motor of the car for the car to move. Some of the mechanical energy will be converted by the dynamo into electric energy. And this electric energy will be converted into light energy, sound energy, and heat energy. Law of conservation of energy. Here is a question for you. Can you create energy? Can you ever create energy? Can you ever destroy energy? What do you think? The answer is no. Energy can neither be created nor destroyed, only converted from one form of energy to another. Now, can you name 5 technology applications showing energy transformations? Nuclear reactor. This will transform nuclear energy to electric energy. Solar cell. From solar energy to electric energy. Electric motor. From electric energy to kinetic energy. Television, electric energy to light and sound. Cellular phones, electric energy to light and sound. What is the relation between energy and environment? From the benefits of energy and energy transformation, we use energy resources in our daily life. Energy transformation from one form to another to be used in our daily life. But sometimes, energy transformations have harmful effects on our environment in the form of car exhausts causing air pollution, chemical pesticides causing chemical pollution for air, land, water, and also food poisoning, nuclear and chemical weapons causing mass destruction, loudspeakers and construction tools causing noise pollution, explosives causing killings, disfigurements, and permanent impairments, networks of wireless transmitters of cellular phones emitting harmful electromagnetic waves. Time for questions. Now choose the right answer. Light bulbs convert which type of energy to which? Heat to electric, electric to mechanical, electric to light. It's electric to light. In simple electric cell, which type of energy is converted to electric energy? Simple electric cell. Chemical. Do you remember the lemon battery? In simple electric column, the cathode is made of zinc, aluminum, copper. It's zinc. If the mechanical energy of a pendulum is 150 joules and its kinetic energy at rest is 130 joules. Calculate its potential energy at the rest position. At rest position, potential energy is equal to mechanical energy minus kinetic energy, which is equal to 150 minus 130 equal 20 joules. Dear students, thank you for watching. See you later in other science episodes.